Okay, now question number 21. It is saying that a high frequency as AC signal is applied to a PMC instrument. If the RMS value of the AC signal is 2 volt, then the reading of the instrument will be, the correct option is option A, 0, because PMMC instrument, they are used to measure only DC, and here as the input is AC, the reading of the instrument will be the 0. Now question number 22. Also, if the circuit shown in the figure 1, if the ammeter indicates 1 ampere and the voltmeter having an internal resistance of 1 kilo ohm indicated 100 volt, then the value of the R would be, so they are asking about the value of the R. Okay, now we need to know the value of the voltage and the current so that we can find R. Now it is said that a voltmeter is connected across this resistance and this indicates 100 volt. So the voltage across this terminal also is 100 volt. Therefore we know the value of the V. Now we need to find the value of the current. So the total current, that is the ammeter is indicating, is 1 ampere. Now as there are two branches, current will get divided. This voltmeter has an internal resistance of 1 kilo ohm. So the current that will be flowing through this resistance is current 1 ampere into this resistance, that is 1 kilo ohm, by the summation of these two resistances, that is 1 kilo ohm plus R. From this relation we will get the value of the I that is flowing through this resistance. Let me show you. So current through R, current through this resistance is 1 into 1000 ohm by 1000 plus R. This gives the current through this resistance according to the current division rule, which is this. The value is this. Now in order to find the R, we need to divide the voltage, that is 100 volt, by the current. So if we divide, we will get at the end R is equal to 111.11 ohm. So our option A is the right one. When does the arc interruption in oil circuit breaker take place? Arc interruption takes place when current goes through 0. Current goes through 0. Arc interruption in circuit breakers takes place by two methods. One is high resistance method and another is zero current method. This you can keep in mind. Zero current method is generally used for high voltages AC circuit breakers, and high resistance method is used for low voltage AC or DC breakers. Achha. Now the ratio of making to breaking capacity of an extra high voltage circuit breaker is always more than 1, because making capacity means breaking capacity into 2.55. This is the relation you should know. Therefore, making capacity is always greater than breaking capacity. So the ratio of making to breaking capacity should be always more than 1. Question number 25. What is the major cause of the failure of the circuit breaker? Trip circuit open, trip latch defective, spring defective. These all are the cause of the failure of the circuit breakers. Question number 26. To determine the polarity of the voltage drop across a resistor, it is necessary to know the direction of the current through the resistor. Option B is the right one. Question number 27. Which type of earthing is preferred by transmission lines? The earthing that is preferred by transmission line is strip earthing. Option C. Question number 28. If P is the power of the star connected system, then what will be the power of an equivalent delta connected system? Now, the power of the delta connected system is always greater than the power of the star connected system, and the power of the star connected system, if is P, then the power for the delta connected system will be 3P. Question number 29. Input resistance of a common emitter transistor of the order. Now this answer is option B, 1 kilo ohm. We should discuss something. Generally, the input resistance for a common base transistor is 100 ohm, whereas input resistance of a common emitter transistor is 750 ohm, which is nearly equal to 1 kilo ohm. So the answer is 1 kilo ohm. And for common collector transistor, the input resistance is 750 kilo ohm, whereas the output resistance of the common base transistor is 450 kilo ohm, and common emitter transistor is 45 kilo ohm, while for common collector transistor it is only 50 ohm, and the voltage gains of common base transistor is 150. For common emitter it is 500, and for common collector transistor it is less than 1. I have made a chart which can help you. This chart you can keep in mind. This is the input resistance, output resistance, and voltage gain. Okay. Now, the electrostatic stress in underground cable is is always maximum at the conductor surface and minimum at the sheath. Now, the more you will go far from the conductor surface, the electrostatic stress of an underground cable will decrease. So it is minimum at the sheath, because sheath is the outermost layer. Beneath this sheath we have armoring. Beneath the armoring we have bedding. Beneath the bedding we have metallic sheath, and beneath the metallic sheath we have paper insulators, and beneath the paper insulator we have these conductors.